Hello, my name is Betty Du Bois, and I'm a network detective. Today I'll show you how I solved the mystery of the slow network. A customer called me to let me know one of their users was complaining about slow response time on their guest wireless network. I grabbed my Air PCAP cards and went to the customer site. No one was sure which channel was in use, so I used all three cards to lock onto channels 1, 6, and 11 and capture the traffic to disk. Physical issues will manifest themselves all the way up the OSI model, so it simply saves time in the long run to start all network investigations there. I focused on signal strength, noise, and 802.11 retransmissions as my suspects. Let's look at channel radio frequency over time for the entire 6 hours that I captured. I see a nice strong signal strength, with noise being right at -100 dBm, which is best case scenario. That eliminates wireless noise as a suspect for the network as a whole, but what about my user? That's who I'm really interested in. The only thing that I knew about the client was his MAC and IP addresses. Let's look at 802.11 retransmissions overview. Remember, wireless is still a contention-based environment, so retransmissions due to noise and collisions are normal. The question is, when do they become excessive enough to be noticed by the user? For the 6-hour trace file, only 3% of the packets were retransmitted. That's below my 5% normal threshold. However, my user's MAC address is number 5 in the retransmissions by host list. I need to know if my user is experiencing excessive retransmissions. So I'll open up the top MAC sources view to find his MAC address and use that to drill down for retransmissions. He's number 3 on the top talkers list. Never a good sign. I'll drag and drop retransmissions versus normal traffic view onto my user's MAC address. Well, his retransmission level is twice as much as the network as a whole at 6%, but hardly a smoking gun. I'll need to look at the traffic he's actually sending to get more clues. I'll go back to the top MAC sources view and apply IP conversations to just my user's MAC address to see who he was talking to. Whoa! Nobody needs to be talking to that many people. I definitely think he has some sort of virus or infection going on. Based on the size of the circles, it looks like he's hitting almost everyone with a comparatively small amount of data. The largest amount of data is this conversation. I'm going to resolve the host name to see who it is. It's the local DNS server. Oh yeah, this guy's infected. The large volumes of DNS queries are a dead giveaway. Now I want to see what type of traffic he's sending. I'll select the user's IP address and drag network usage by traffic type onto the conversation ring. 87% email. Looks like he's infected with a spam bot. I'm going to go ahead and send this traffic to Wireshark to verify the infection versus someone who just likes to send a lot of email. I'll put in the filter bar smtp.request.command equal to mail. If this was actually all his email, then only his address would show up. I met the user on site, and he sure didn't look like a Susanna or Tammy to me, or any of these other names. I could follow TCP stream to actually look at the email, but I'm afraid this might turn into a whole different type of video. Now I'm curious to see if my user is the only one who's saturating the network with this type of traffic. I'm going back to my top MAC sources view and dragging IP conversations onto the top talker. Aha! Seems my complaining user is not the only one who's infected. everyone is contending for a limited amount of bandwidth, and this spam bot is slowing down the entire wireless network. Combining Pilot, AirPCAP, and Wireshark made it easy for me to solve this network mystery. Thank goodness I can offload the cleaning of these computers to the desktop support team. See you next time. I'm off to use Pilot's report feature to create the documentation for my invoice. To learn more about Case Pilot and the AirPCAP cards from Case Technologies, go to www.casetech.com.